So welcome to what will become the 19th episode of the Minuteman project. Our plan to today is to print a 74-second Benchy. But before we do any of that, I have to fix my own issues. So, my name is Jan, and I fuck things up so you don't have to. Alright, since I had everything like torn apart, Z height of the probe is not spot on. Let me fix that. This time in finished, little bit of stringing. Let's hit another print. Same speeds in terms of printing speed and accelerations, and let's compare them. This is the first and this the second one. One of the main questions in this episode will be why, even though they use the same settings in terms of speed and accelerations, this is 3 minutes and this is 2 minutes 20. So today, among other things, we're taking a deep dive into Benchy slicing.
Da 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 da.
Future Jan here. Right now I'm in the process of getting my final result from this video turned into a 3D scan using this Revopoint MetroY Pro. It would be a great idea to hop now into the video description, follow the printables file, download this exact Benchy, put it on your printer, and then once this is printed, I'm also done with my setup here. So that would be pretty dope. You can have like the end result in your hands as well. Let's get back at me losing my mind over there. Alright, hold up. Let's try to put some method into this. In the last proper Minuteman episode, we printed a sub 90 seconds Benchy. Our ultimate goal is to do it in less than a minute. And so my thinking is, let's divide that problem into half. Print it in 40 seconds. Our goal today is to print it in 74 seconds. We gotta tackle a lot of things I do have on my list, and there will be several parts in this video where I could actually use your thoughts on it. So first off, we're gonna talk pulleys and belts. So after my motor showdown, I pretty much decided to stay on these Nanotech NEMA 23 hybrid steppers. And these like really excelled the machine. Reachable accelerations are just off the charts. Haven't seen that anywhere. I was able to run 200 Gs with these. And all of that is being run on these pulleys. These are 60 millimeters in diameter and polyjet printed in nylon. All of that is coupled with this 2 millimeter Dyneema rope, which is pretty much on here since day one. You can see there is some wear and tear, but mostly because some of the times it slipped off this bearing here and then it was just rubbing against the screw. So this is kind of wear resistant. And I think in terms of usable accelerations, these are pretty much my best options here. But what they do lack, in a sense, is stability. If you have a look at that Benchy here, or not, have a look at this section down here, and how it is not a 90-degree angle over here. Bigger than 90 degrees and this is smaller than 90 degrees. The point I'm trying to make here is, ultimately we want to do a sub 1 minute Benchy. But it would be great if the quality was somewhat acceptable. So just printing fast won't cut it if we want to shift manufacturing to more localized production, etc. We also need good quality, strength, and all that what comes with it. And while all of that can be considered pretty stout, these Dyneema ropes are pre-stretched and all of that, but they will just encounter slightest bit of elongation when they're pulled like with 200 Gs on it. These Pulleys may just twist the slightest bit and all of that. So this is my first thing I want to find out today, because I do have an option here. These are the nylon pulleys that are on there, and these are the aluminum ones I have in stock. So what I try to make a decision on, and I want your opinion on it, should we do the switch? Maybe get a bit more inertia on the machine, so get the accelerations probably down a bit, but therefore have way more stability and rigidity in the system. So to put this into numbers, this one is just over 13 grams. And this one weighs in at 36. So it's not threefold, but somewhere in that range. I mean, there are also like 3 screws in here, which are not accounted for. But it is a major increase, especially because most of the weight is out there on the biggest diameter. The other mechanic that could limit our rigidity is if these things actually do twist under load. And I'm pretty sure it will happen with these nylon ones. We have to find out to what degree. But I think these aluminum ones will be stout enough to get the flex to a negligible limit. So for that, and let me try to get the camera also in here so you can see. So what we got going here is this stepper has one shaft going through it, and it's sticking out on the other side to adapt a resolver or something for position feedback. And I clamped on this older prototype of a pulley, got 2 screws up in here and mounted 2 dial indicators on top. So if I turn this, they're gonna move the same. Now, I will put an unreasonable amount of holding amperage on that motor, 2 amps, and then I'm going to do the same twisting here on the input, and then we're going to see the deviation, because this will have load. I will apply that torque with my hand. This one not. So basically we will have what the shaft does and what the pulley does. This is somewhat scientific. What is not is the torque I'm bringing in. Yeah, so let's switch on power on these motors. So these are zeroed out. And I'm gonna do a bit. So I'm focusing on the right one. This says 1/10 of a millimeter. Left one is about 600ths. I'm gonna do 2/10. And this is about 11 and a half. I'm gonna do 30. This is shy of 20. Let me try to do 40. And it's at 25. Going pretty much back to 0. Let me see how much I have to push it to create a step loss. 50, 60, 70, I'm pushing quite hard actually. And I mean, probably the setup has shifted here. Or the pulley itself also might be. The problem with these CMMs is granite, aluminum, magnesium, brass. There's nothing to stick a dial indicator to. It's kind of a pain for years actually. So let me try again. 70, 80, almost a millimeter. I'm pushing really hard. And I think I have shifted this one. I'm very sure I haven't touched the dial indicator here. So what do you guys think? This is a possible source of error that is being introduced in the system. These pulleys are awesome for what I planned them for. But is it time to sacrifice the last few % of speed in order to get more reliability and rigidity? Let me know down in the comments. And yeah, this is the run out measurement. So this is like our 0 point, and for a full rotation of the bed, it's only going to do like 1/8 of a revolution. But I can't unsee these values. So this is the worst one. These are of course distorted by the screw that is applying holding force, but have a look at that. It's gonna shift like 3/10 of a millimeter. So I can't unsee these values. Let me do one prototype and check both run out and the flex with an aluminum mounted on it. All right, op 1. Retap those threads. This is just SLM printed, so it's going to chase them nicely. That way when we do the diameter of the bore, then we're also cleaning up the bottom of the threads. Okay, operation 2, I put them into some soft jaws and we're going to use this 8H7 reamer to get the center hole to match the motor shaft. Op 3, I used the collet chuck, adapted the raw stock 8H7, and now we're gonna screw this guy on and turn everything concentric to the shaft. And operation 4, mount them on the machine. Well, you gotta admit, those look pretty dope, right? I like the look a lot. But the big question is, how does that translate? And I got no current on the motors to verify my setup here. And you can read like 66, 66. 90, 90, 20, 20, 40, 40. So within a reasonable amount of error, these turn the same. Let me switch on the current. All right, 0, 0. I'm gonna apply torque for 10 millimeter of rotary displacement. This is 10. This is somewhere like 8 to 9. At 20, it's gonna say like 18. I'm gonna do 30. It's like, I don't know, 27, 28. You be the judge on that. Comes back to 0. Next day, I took the chance and off camera I machined all of these pulleys to fit on here. We got these pulleys machined to very close tolerances. I measured all of these diameters, the effective diameters essentially. And now we can set this up and take few things out of the equation. So the run out is pretty much eliminated. And I can set the rolling circumference for each of these motors individually. So we can take a lot of error out of the system. And hopefully we have eliminated the flex to a very small degree. So I did quite some tweaking and this is looking rather promising. So all of them are pretty much as tight as they have ever been, I guess. I'll put the glass plate on top and then we're gonna do some dry humping. I mean, take away those ringing sounds of those bearings there. This is still a sub 3 minute benchy. It's kind of impressive how silent that is without all the cooling air blasting over it. Okay, I've replaced the shitty bearings. Let's just repeat the last coat I had on here with the red filament and try to compare those. So while we're on the subject of pulleys, let's talk for a brief second about our today's video sponsor, which is PCBWay. So PCBWay has been helping out this channel and especially this machine with loads and loads of really cool parts and solutions. So if you're in search for affordable but high quality parts for your project, hop on over to the PCBWay website. There is a link somewhere down in the video description. It gives you a web interface where you can upload all your parts in various formats and an easy selection on all the materials and processes you can choose from. Select the desired quantity and then head over to the checkout where it will give you an instant quote on that. If there's a problem with your parts, an engineer from PCBWay will contact you and find a solution that works. The quality of those parts have been shown on my channel frequently, and I really enjoy the speed of the manufacturing and delivery process. So thank you PCBWay for sponsoring that video. Let's get back to the content. I'm a bit on the impression that I'm living on a tangent here again. In terms of benchies, same code, same everything. This one has been printed with the aluminum pulleys, this one with the nylon ones. And if you ask me, they are within margin of error and totally look the same. The thing I was after, pretty much not gone. And I also printed one benchy while input shaping was off. And you could see how much of that rounding of the corners the values in there are doing. So I have to do new input shaping profile anyways. It's too early to draw some conclusions, but so it's really hard to explain what's going on here without being on the machine. So everything is dead silent, motors, granite of course, these guys, hot end. The glass plate seems to be the verdict of kind of stuff that's happening between 150 and 230 hertz. And then there's a lot of stuff going on in here. I have no idea where the real resonant frequency of this whole system is, because I mean there's basically no reference to it. Is it possibly that this is somewhere out of scope? 300, 400, 500 hertz, the moving platform, and we're just not measuring it? I mean, all the input shaping I've done so far, and now we're at, this is 170. Now it's starting to become violently loud. It's definitely the glass plate in that area, but of course also no idea how much that cable influences everything, but it's really hard for me to set up like direct wiring to that. So I think for today I'm calling it quits here. I'm not making any progress in terms of input shaping. I'm cold. Everything starts to vibrate really hard and I have no idea what to do at that point. I think what I need is a good night's rest and sleep over that, as well as go really deep into finding all the resonant sources on there, fixing the glass plate, relapping everything. It's going to be a short one. Yeah, so I apologize for... I don't know. I wanted to do something entirely different in this video, but this tangent like keeps me hooked to it. And I had like, this is the 4th day I did off camera and trying to figure stuff out here. So let me at least try to get you up on speed. So everything regarding the input shaping, which you probably have seen the intro to, yeah, led me to a very big tangent. And this is, yeah, what the Pareto principle basically tells you. Last 20% of the result are 80% of the work. And I've been quite an integration hell here. So to get somewhat clean readings off of my LS2DV acceleration sensor, I first started with getting like noise down, etc. I tried different variation of cables. This one doesn't seem to be influencing the measurements, at least on the measurable scale. I tried to bring noise down by choosing a good amount of current on the motors. So and then I got on a tangent with the Clipper integrated input shaper routine. What I was trying to do, since my moving mass is so little, I was kind of expecting the results to be at the very upper end of the spectrum that like usual input shaping is measuring to. And this turned out to be true. So the 200 Hertz region, in which most of standard clippers pretty much fall into, is not enough for my system. Then I did a lot of research in how to like get the standard routine to have higher like sampling rates on my accelerometer to basically measure, let's say, to 400 Hertz. And this seems to be necessary. So my biggest peak in the whole system is around 200 Hertz, but like in the range from 170 to 220, somewhere in that. And in that regard, Clipper is confronting me with loads and loads of restrictions. And what I found in my research is basically this here. This is the Shaketune plugin from ClipPane. And this has some very useful features already built in. So for starters, it lets me run the frequency response all the way up to 400 without even messing with any of the like background scripts. The measurements are like matching with what I got on the Clipper side. And one of the most important things, it has a macro already built in to actually Shaketune. I can go in, take all the peaks from my measurements, and then excite the system at that frequency and really have a look what is happening here and what is the cause of all of that. And I will be showing you a few of those peaks I found. So for example, I can take this macro here, type in any frequency I want, a duration, an acceleration and the speed, and what axis I want to select. And in this case, the 80 Hertz peak can be seen here as a standing wave in my outside strings that are like going around the moving platform and connect motors A and C, which is this and this one. And then I have the same thing with B and D. Moving on, this is 100 Hertz. You can see the standing wave has disappeared from here, but now you can see that those springs up here are starting to resonate real bad. So we do hit the resonant frequency of those springs at around 100 Hertz. This is 160. And this seems to be exciting my build platform. By reducing the gap in the air bearing, you see that the vibration gets a lot less. And then, I think this is probably one of the most interesting ones. So the build platform is sitting right in the middle of my treble. And when I go with 200 Hertz, I'm just going to trigger that for a very short amount. You can see that we're basically triggering the resonant frequency of those strings leading to the build platform. But in this case, this is motor A and C. Those are connected. Only these two are resonating as hell. I'm gonna excite these at a very slightly different frequency because these are either a bit less tightened or a bit more. And basically in most of the scenarios, all of that is being brought up to this glass plate, which is gonna do all sorts of weird movements as well. Now comes the complicated part. So I do have at least 5 to 6 resonant frequencies of different components per axis. And since my system isn't symmetrical, I do have different peaks on different axes. And also, the amount of air I'm going to be pumping through the air bearing does have a big influence on all these components as well. I'm going to show you. So all weird stuff is happening And to make things even worse, it's gonna change depending where I'm at in my travel range. And what this feels like is that there isn't a perfect solution to all of this that makes all my problems go away. There's just the biggest compromise. So what I'm going to be doing now is implement a few of low-hanging fruits in terms of getting resonant frequencies down. So there were a few possibilities by, again, having a closer look at the gap between the build plate and the glass here. Then we could add something here on those posts. I do have some terminals here where we could effectively get the rope length down and increase the resonant frequency to a level where it doesn't bother us. And ultimately, I'm gonna decide on a shaper that we're just gonna test here and leave for the time being. This time I don't wanna go with something that has this much smoothing than prepared to what we got early on. And then we're gonna go back to printing, because this is what I wanted to do in the first place here. Not fool around days and days in a freakingly cold company here. So let's do that. All right, before we get into that here, I want to be showing you something which I'm really excited about. Well, at Formnext, I got in touch with the guys over at Prusa. We talked a bit back and forth, especially about what I'm doing here, and they pretty much asked me if I'm interested in having a Core 1L, which the natural question is, hell fucking yeah. And right now I'm using it to print parts which I hope fit over the strings on the outside, and we're gonna see if we can get those vibrations down with the help of this piece. And while we're on the subject, let's talk about Prusa a bit. And this is not an ad. I want to be very specific about that. And they told me to not make it an ad when I'm gonna speak about this printer, but I'm a huge Prusa fanboy. This MK3 is by far the most reliable machine I've ever had. This is just shy of 420 days of real printing time. And apart from things that were clearly my fault, this never failed me. I never lubricated the axis or something. It just worked. And I got a suspicion it will be the same with this unit. And if not, let me tell you the tale of the failures I had on the Bambu Lab machines. You gotta admit, those Bambu printers just work. They're pretty great machines, but the problem lies there when they don't. And I actually had failures on both of these X1 carbons. And on both machines I had the cable going to the heat bed breaking loose or something. Basically the thermistor was reading some gibberish. So of course I contacted them. To get both of these machines running took around 6 weeks to get everything there. So first of all I had always a conversation with someone named Peter, which was clearly giving me pre-generated messages. Then I had to upload pretty much all of my printing history, so this lies now somewhere on a foreign server. And then the manuals I had to follow in order to change the cable out were okay-ish, but it was just a process which took loads and loads of time, including getting off silicone rubber on all these mating connectors, basically stripping down the whole machine. And it was just not something I want to be dealing with in the future. And this is where the value of those machines are actually sitting. So not long ago, Prusa went ahead and published all of their freaking files as a step and a fusion file for the Core 1 and the Core 1L, I guess. And I think this is just such a smart move to do. If I got a problem with that thing here, I'm pretty sure I can fix it on my own because it uses standard parts, which everyone uses, basically. And if not, I'm pretty sure if I would call the Prusa hotline right now, I would be getting somewhere that speaks either German or English, and I will be getting replacement parts in a matter of a very few days. And if you ask me, I value that a lot more than just a few bucks and a comparison which one is cheaper or more expensive. I do value stuff like repairability, how someone handles my data. I have no problems getting the analytics down to the guys at Prusa because I'm pretty much aware of how sensible they think those informations are and how they handle them internally. And also, you know, I've been doing all of my stuff here as open source. I'm giving away all the information about high-speed printing. I developed this hot end here, which you can download, and I got all the findings here up on YouTube and over GitHub. You can build this by yourself, and I value that so much that someone like Prusa is also upping all their stuff to the internet. Basically, they have been a huge part of building slicers that others basically copied and then put their own intelligence protection over it. And I think this is just a mess. We should go back to printers that are in the wrap fashion and not being injected molded to the last piece, because you can't repair that with the tools you got there. This one, you can. Let's talk for a brief second about cooling ducts. So I've been experimenting a lot with these kind of pneumatic air knife thingies on the Minuteman machine. And you know the deal with SLA. It isn't as fast in terms of getting parts somewhere installed as FDM. What I do think is that Prusa has one of the best filament profile library out there in its slicer. And they also included a pack of this polycarbonate blend carbon fiber material. And I printed these parts on it, which are nowhere near easy to FDM print, especially with those very thin walled outlets here. But when I installed them on the machine, they are in direct contact with the nozzle they are holding up. And I thought, well, I could just prototype it and maybe do 2 or 3 prints and get my results, but no, they're on the machine for like the entirety of my testing here. And this is a game changer for me, at least. All right, so let's try to capture all of that here. I got the Mac base mounted to this lapped holder. So I have the reach over here, and for the 1 micron dial indicator that's mounted, that's like, let's say, plenty of reach. But I need that in order to get all of them in the same setup. So this is basically near 0. And when we go over to our first pad, let that settle in, that's like 9 microns of clearance. So we got 3 microns of clearance here. 0, minus 10. Yeah, that repeats. Minus 10 microns. Can you see that needle move? It's got like 0.02 of a millimeter where it is rocking, because it's basically, I mean, it's resting on these 3 pads. But if I push it down, we're also 10 microns under compared to 0 on our standoff. So basically this reads pretty good. Got like 1/100th of a millimeter of clearance between the glass plate and the granite. The granite is pretty much a reference. This will be flat as fuck, minus what I did to it over the last couple of months. And the glass plate is pretty much a 5 millimeter thick piece of float glass. So I guess this can be considered pretty flat. At some point I want to change this out. Okay, I installed 2 fixes for now. The first are these 2 blocks, one here, one down there. These are pretty much just there to keep both of these ropes apart, because I was noticing that they were like influencing each other, and it was like a lot better when I just stretched them apart with my hands. And then on the one side I installed this channel here. This is just being held with some screws and hot glue. And now we're going to run 80 Hertz of excitement. Right now it is pretty much dampening the resonance, because this is a pretty flimsy part. And basically what this means is we're going to offset the resonances to some other unknown point. So I think I will keep this just on the left hand side for now and see how this works. I'm going to do a final run on the input shaping, choose a shaper, and then we're going to go back to printing. Alright, at least we're printing again. So this has been before, this has been afterwards. You can see before we had a smoother shaper type installed. Now this is a classic shaper. So let me build a test slice, decide on what filament we're going to use ultimately, and then start iterating on, seeing where we can go quality-wise. So loads of stringing, but 1/27. I will go ahead, take the same filament. I got a spool of black from them, and I will be respooling that to fit it on the machine, and then we'll make a decision if the red or the black one is the better one to judge the quality, and then real iterating starts. So probably you just saw a dry run of a minute 13 print. This is like pretty much a shot in the dark with mostly values that are somewhere in the middle of where I think they have to be. I would have liked to have been there like 4 days ago. I've been running into all sorts of weird issues, and for the last 1.5 days I've been chasing my own tail on the winch kinematic. And still, I can't really tell you what is happening here. The tension is going out of the ropes depending on where on the travel I am, and it's weirdly not reproducible, and sometimes it's in other axes. I have no idea what this is all about. I got on the latest bleeding edge Calico firmware, have systematically gone through everything I have done and changed over the last couple of days, and as you can see, most of my mods are gone for now. I tried to reset it to a known point where I know it was working, and since I have run the 1 minute 13 print successfully, I'm just gonna wing it, and if it runs through, I have at least reached my goal, which is printing a sub 74 second Benchy. Yeah, my plan is to iterate back and forth, but I need to have a reliable setup, and I don't really think this is it right now, but let us just run that, hope it's running through, and then we get hopefully a first data point. Man, I've seen worse. I'm also having seen better, but let's go again. Oh yeah, there you have it. Same shot. 1 minute 13. Obviously, you've seen me deciding for the black filament. I mean, in direct comparison, the black one does show every defect, while the red one is pretty good at hiding stuff. So my plan was to go with black, do the experimenting with that, and once everything is as dialed as possible, I'm gonna switch over to the red one. Let me do a bit of iteration, and if I mess it up and the next print destroys everything, I do have at least something in my hands. So step loss at the chimney. Okay, way more aggressive shaping. Let's see if it holds up. Holy moly. Again, 114. I'm quite impressed. So clearly not enough temperature here on these layers. Alright. After pretty much 1 week of continuous hassle with the machine, I'm finally at a point where I want to be initially. And probably if I just had not started messing around with the pulleys, I may have just been able to just run and conduct these tests. But now here we are. This is all of them are 1 minute 14 prints. And I got a lot of things pretty much dialed to a point where I think it is healthy. And yeah, there is temperatures and shapers and whatnot. And yeah, the rest of the time I was fooling around with pressure advance. And now I got a few last variables to get into this mix. And then we're gonna do a run where I do overlay of clipper and all that. And this is the last piece of the puzzle. 2 bar, 3 bar, 4 bar and unregulated cooling. And I like the more the better. It is as always. I'm gonna let all of this cool down. Motors are getting pretty toasty. Then we're gonna do 2 times the money shot on 2 filaments. and then I'm gonna explain everything that went into this slice and whatnot, so you guys can reproduce all of this, if you want to, at least. Awesome! Lost communication with the MCU. Sweet! What the hell? "20 consecutive prints. Worked flawless. I didn't touch anything. The moment I want to do like the record run, it's the same each and every time." And also, do you remember like episode 4 or 5? It's back. But also look how dirty it is. Maybe this is the root of it. I've never been the best with hygiene, so this is where it shows. You know, maybe it's true what they say. Stopped piepen and kraken. Let's go. Third time's the charm, hopefully. That worked! So quick, let's get the red one and be over with it. There you have it. In case you have been wondering if I have been speeding up all my prints over like 19 episodes and probably 25 hours of footage. Nope. So these are the two specimens we just printed. I did another print of the red one and went ahead and just clipped off some of the stringing marks. And now we're gonna go ahead and make the scan that you saw at the beginning of the video and hopefully have on your printer right now. So let me walk you through on how to get accurate scans of parts like these or anything else apparently. Alright, so welcome to my desk. This is not the first Benchy I'm scanning. I was preparing for this here. What I found out the hard way is a Benchy is pretty much not just a benchmark when it comes to 3D printing, it is also when it comes to 3D scanning. To make it a bit easier for us, I used some scanning spray on here to have a fighting chance of seeing all the details that are on the inside. It is not strictly necessary, but if you're after the last few percent, it does make sense. So this is the MetroY Pro by Revopoint. This is the scanner we're going to use. And what is also included in the package they sent over is this turntable, which is connected via Bluetooth, or I can push the buttons. This makes scanning of such a detailed and intricate object so much easier. Let me walk you through the process of scanning a 3D-Benchy. Alright, so let's do a new project, world record Benchy. And what we're going to start with is cross laser line scanning. This is by far the most efficient and fast way of acquiring data. So we're going to hit start and I'm going to do a rotation here. And the laser is going to instantly collect data about the object there. The dots that are popping up in red are the marker objects. It kind of needs that to track where everything is, and once you start your scan, this whole setup should not move. And so you can see everything that has gone bluish is it has gathered enough data. But what we have to do anyways to get a full scan of this object is to scan it in multiple orientation and then put it all together. We're gonna go with a different angle here to cover more of those surfaces from the deck area. And since we have gathered most of our data, I'm going to stop it here and then I'm going to go pause and switch the scan mode to, let's say, single line mode. This is basically not as fast as cross laser line, but it will allow you to focus your laser light on a very small portion of it. And we're just going to do that. Can zoom in here. And now we try to cover all this here, which hasn't been scanned before. Gonna hit start again. And now I try to get in here and collect as much possible data from the inside of the Benchy print. This is kind of the hardest part to do. I mean, it's basically light technology. So if light doesn't reach the object you're trying to scan, it pretty much can't scan it. Alright, so let's leave it at that for this second. We're going to do all the post-processing later on in a batch. But this is what we got, and what you can see is what we're missing is pretty much the whole bottom side of the boat, as well as some information in there. And let's try to fill that. So for the next scan, we're going to put it in this orientation. Start with cross laser lines again. Hit start here. You can do that via Bluetooth, but I find it very handy to just do it manually. And have a look here how fast we're gonna get a complete model of pretty much the outside hull line of that Benchy. And we're gonna talk about that in a few minutes. This is not fast to see the world assembly. And again here, we're gonna stop this, switch into single line laser mode, and then fill all the little details here. So let me do that. Yeah, and for the last, we're going to try it in this orientation. So basically, I've tried a bunch of other objects which are just, most of the time you basically just need the front face or something to attach something to or design sheet metal around, and that totally works with just one facet, and you basically have a scan ready in 15 seconds or something. Getting every single aspect of a 3D model is kind of a different thing. it needs you to have different orientation and then merge all the data together, which is not a problem. We'll do that in a second. Again, this is kind of a benchmark of a really hard to 3D scan object. I mean, 90% of the time I'm spending here is to get all the data from the inside of the model, so basically in that cabin. Without that, we were already at the printer again. Okay, once we have completed all our scanning, we're gonna go with point cloud fusion, and we're gonna choose the quality version of that. It's gonna take some time. It says 10 minutes, but in my experience, it's more like 2 or 3. Okay, once done, we're gonna get rid of everything we don't need. And what I found is it is always a good idea to get rid of the base where your model was standing on, because these information will not be the most accurate, and you will have those contained in another scan. And now I'm gonna do that with all of the others, and then we're gonna do the merge. And we're gonna select basically model 1, 2, and 3, and you can see them here. And then we're gonna go just by clicking the auto button. It's gonna set them on top of each other and align them. And here you can see this makes sense, and we're gonna hit generate model. And now basically it puts together all of these point cloud data. Here is everything combined. We're gonna go and do some post-processing. There are a few things that are isolated from the main model. We're gonna get rid of that, and some overlapping things. We're also just gonna go with standard settings. And then once we're satisfied, we're gonna create the mesh. We're gonna go with quality mesh, basically all it's got, so biggest file size. And yeah, there you have it. This is the complete model of our 3D-Benchy. So let's export that and then import that into Prusa Slicer. And select the face down here. Reorient this a slight bit to make this a solid surface. And since, of course, I did have overhangs in the print, so it does make sense to use some kind of support material. And then send this off to the printer. So I think this is a pretty cool addition. Of course, scanning, slicing, and reprinting does take a lot of details away, but you can be the judge by yourself on the 3D data that is available on the printables. And if you've actually printed the part, then you're pretty much holding this in hand here, which comes pretty close to what I got here. So let's talk about the results of all my testing here. All of these 3 benchies are printed in 1 minute 14, just like all these other documented data points. I think it's time to show you all the secrets I have used to make this happen here. So full transparency as always, giving all the information away. So let's reveal the filament we have been using for the test. Both the red and the black one are Volcano PLA by Form Futura. And this is a quite interesting material for this specific use case. So it is been advertised as a PLA with ABS-like properties. What I have here is an ABS test specimen I did over in the Filament Shootout series. And the problem with ABS was it showed a lot of potential, but it didn't scale with cooling. So the more cooling I threw on it, the more brittle the layer adhesion became. Certainly I was drawing too much energy out of the system to remelt the previously laid down layer. This is not the case with this material here. Even if I squeeze it really tough, the layer adhesion is pretty good, and I don't see a difference in how much of cooling I throw on here. I have no affiliation to foam Futura whatsoever. In this particular case, it is the best filament I have ever tested. But one thing I want to be specific about, I have used this Fiberlogy high-speed PLA for pretty much the eternity of the last testing. This has been my reference for pretty much everything right now in terms of high flow applications. But if we're in reasonable range of temperatures, I can get twice the flow out of this filament. You choose the filament for the specific use case. If my print would have been a bit bigger, this is the faster option. This stuff is really good in terms of solidifying at high temperatures, basically ABS-like parameters. So for our Benchy testing here, this is awesome stuff. Let's hop to the machine. So I'm quite in a debate right now because I couldn't reproduce the speeds I had on before. All the prints you've seen were at 750k accelerations. This is really, really high. Don't get me wrong, but it is half of the acceleration I could do in the last episodes. And truth be told, I can't really put my finger on why that is. So to make the sub 1 minute Benchy a thing, I have to get back to these values. If not, I don't stand any chance. And I'm in a debate with myself if I should try to do that with this exact setup, or if I have to like scratch all of that, make a fresh start. I think the motors will stay no matter what, as well as the hot end extruder setup. But everything in terms of pulleys, ropes, build platform, standoffs, and glass plate, all of that could be replaced with a version that combines everything I've learned over the past, 16, 17 months. But this is how engineering goes. Sometimes taking the step back is kind of the most efficient way. There's this saying of the shortcut is the longest connection between point A and B. So I will make my mind up about that. Either way, you're gonna see it. In like the 20th episode, rumor has it this will be the last of the Minuteman series. So I don't know. If you have been enjoying this content till now, it would be a great time to consider subscribing. If you want to have like early notifications to stuff, see the videos a few days before, there are two options. Either check out my Discord, there is an active discussion about all these things going here. So basically the first sub 75 second Benchy has been like 2 weeks before on the Discord. And pretty much the same goes for my Patreons. Thank you guys so much for enabling me to do all of that here in my free time. Thank you. So now let's go over the other very important step to make the sub 75 happen, which is slicing. Yeah, so what you're seeing here is pretty much the Benchy that I used for the sub 90 second. The thing you gotta pay attention to is the total weight. It is estimated at 8.7 grams. And to make this happen in this time, basically flat 1500 millimeters a second printing speed and then 150 Gs of acceleration with a square corner velocity of 100 millimeters a second. Basically, this is where we have been. For this part, I had some help. Actually, Nico helped me a lot with his slice. He's also speedrunning, and I think his last attempt were 148 on a self-built Voron. I'll put a link to his Instagram and other social media accounts here. So thank you again, Nico. Over like 18 episodes, I have been like training for that exact moment, because I have done the pinky move and just used my bronze and made this machine as fast as possible and get as much material out there, basically max everything out before we do the brain move, which is actually do proper slicing. You can see that pretty much all of that is weird zigzag moves that are not optimized for anything. When you have a look up here, it's got an alternating pattern to it, so left, right, left, right. Yeah, so the slice you've seen today does look like this. It's this boat here. And the first thing right off the bat is the weight savings. So this is 7.4 grams. So I think it's 1.4 grams in savings. And this is estimated 106, but the one I was running had like 0.2 minimum layer time in it, I think. Yeah, this comes to 1 minute 11. In this case, it adds 3 seconds to the estimation, so this is the 114 slice. You can see here a few things that are totally optimized for speed printing. So basically all the infill here has just one direction, the long one. I'm not even combining infill because this is another topic in terms of flow. We are again right at the 160 mark or something. If we would like combine infills, then you can basically double that for that move. I mean, the hot end would potentially do it, but then again, I would have to up the temperatures to actually extrude the filament, and then, yeah, all the rest that needs cooling is worse again. In terms of weight, I had all of them on the precision scale, and it seems like that all of them are missing 0.2 grams. All of them are weighing at 0.2 something. But since I had all the temperatures in there, I don't think this is a bottleneck thing. There is something wrong with the density over here. I'm pretty sure about that. So 7.2 gram is what I'm actually be printing there, and this is really, really consistent. So speeds, 1500 millimeters a second printing speed, 750K accelerations, 100 SCV flat. Then there are like a lot of those small solutions. So basically the internal bridging that is like put down before the internal solid infill comes. This has a setting for how much of a density you want to have. I think this is somewhere in the 30 range. This is a second basically. And you do that for all sorts of weird things. Having a look up here, you see there was zigzag lines everywhere before. Now it's just basically perimeters. And the same goes for the top here. Very light bridging, very light infill, and then very sparse top fill there. So because we reached a point where reasonable speed increases actually don't make that much of a difference. We're at 1 minute 11 and 750K accelerations. Let's quadruple that. So 3 million millimeters per second squared on everything. What's your estimate? So we saved 11 seconds on the slice. I can't run that on here consistently. I've never done that. But you see how far you gotta go to get a few seconds off of there? So from this point on, with the state of the machine and the possibilities with open loop steppers, there's only the way of doing that with software and slicing. Once we're done here and reached our goal ultimately, I don't know, I'm open for any motor solution that is just off the charts. Servos, BLDCs, something from RC race cars and whatnot. I'm open to put anything on here because I got a very rigid base, I got a very light moving mass. We can do all sorts of weird things with it, but for now we're stuck with probably the most potent steppers I could find for this kind of setup. 0.2 layer height, everything is 0.5 layer width, 2 wall loops, 3 top, 2 bottom layers, 10% infill, and yeah, you've seen my speed tab. And while we're on the screen, These are like the cleanest input shaper results I do have up to this date. And I wasn't showing them in the second because I'm well aware that there is still a lot of work to do and don't want to put confusion out there. So this is the x-axis, peaking around 200 Hertz. This is pretty narrow and then gets like pretty wide down there. Y is a bit different. It's going to peak around 160, 165 Hertz. For now, I was running with the smooth EI shaper, or smoother basically, on both axes and was iteratively setting the frequencies and seeing what kind of result I was getting. For now, I was running the LS2DV sensor, which turns out to be a noise problem up here. Thank you again for the people over at my Discord and also the Coleco one, because they were explaining me quite a bunch about spectrograms and I didn't know how to read them, to truth be told. But now I know what I'm looking at, and then I ordered an ADXL3 45, but this never showed up to my door, so I have to postpone that. And we'll have to do input shaping again either way, so yeah. This is basically where I'm at. Usually 200 Hertz is like the cutoff frequency for anything that standard printers are doing. And most of the peaks are somewhere below 100 Hertz. If something is way up there, then basically something is wrong with the measurements. This is what the guides say. Not in my case. The moving mass is so light and there are so many different components involved, like the strings and springs and whatnot. So yeah, this is basically what I'm working on and I have to figure that out all by myself. So again, if you got any more knowledge than I do, feel free to ping me up on wherever you want to do that. This is and has been a community project, so if we succeed at the end, we're going to do it as a team, so there you have it. And yeah, it has been a pleasure to have you here on this video that has, again, gotten pretty long. But it is, as always, research is not predictable. And while I thought I would just have a look at the Pulleys, you saw what I ended up with. I scratched all my previous things and ended up in a situation where I don't want to be in, actually. So I will figure that out. I will be hyped if you type anything regarding this topic in the comments, either if it is criticism or any help or any suggestions or what I should do next or whatever. I'm open for it. I'm gonna read all of them. So, this has been episode 19. 20 is gonna be the big one. The one we've been working on for a long time now. My name is Jan. And I build stuff so you don't have to. See you in the next one.